This problem is a continuation of the one that I did in the previous video. So we have made that compound, and it was done by using a Michael reaction, essentially removing one acidic hydrogen here and then doing a Michael addition. We got to that point, but now this we're going to be using in a different way, and we got to go here. That's our target molecule, so we're going to explain how this reaction happened and what do we need to use to get to the final compound. So let's get to work here. So first thing that I see here, basic conditions, water, and then acidic conditions. Similar to the other problem that I did before, this is used, step one. This, I'm going to write it down here, is the ester basic condition, ester hydrolysis. Then this is used to protonate the carboxylate. The final step is going to be a decarboxylation. So we're going to walk through that. Combining steps 1 and 2, we're going to get a carboxylic acid here. So I'm going to say 1 and 2. Let's combine those two steps. Simply acidic word cap after the ester hydrolysis. So the carboxylate will become a carboxylic acid, and here's I'm trying to make it smaller. So now for the step 3, that's a decarboxylation. What we're going to do, similar to what I did in the previous problem, we're going to be rotating this bond here so that I have the OH next to the carbonyl. So in doing so, this is not a reaction, I'm just drawing a conformer. So let's do this the same as this here, which is simply redrawing the carboxylic acid this way. 1, 2, and then the carbonyl group. All right. So once I am here in this step, for the decarboxylation step, you're going to be doing that and that, and this is going to form. You're going to, this section here is carbon dioxide. So minus carbon dioxide, what you're going to form, so minus CO2, you're going to have here OH, double bond here, and this is gone. So now I'm going to add the other fragment. So this carbon is this, 2 more carbons, and then the carbonyl group. So that right there, that is an enol, and that will be tautomerized. And I'm thinking where I'm going to draw this. So equilibrium should be shifted to the keto form, and that's your compound right there. So ester hydrolysis, acidic word cap, decarboxylation. So we're here, and this is compound D, what we have. Now, let's work on the other steps. Here what it is, we're using, instead of sodium hydroxide, which is what we use for the hydrolysis, using sodium methoxide. So this specifically, we're going to be doing now an Aldol reaction and then the Aldol condensation because we're going to have heat. So the first step here, when you do, this is going to be an intramolecular Aldol reaction. And this happens when you can make 5 or 6 member ring. So if I remove one of the, with ethoxide, one of the hydrogens here, one of the acidic hydrogens, I will create an enolate, and that will attack over here. So let's see what we have. You're going to make a cyclic structure, and that will have 1 carbon, 2, 3, 4, 5, and 6. See, so now I'm going to simply redraw this as a 6-member ring. Carbon number 1 here is going to have, let's do it, well, anyway, that will be O negative, and that will have a metal, which is that. And then if this is 1, 2, 3, 4, and 5, I'm going to have a carbonyl, so 1, 2, 3, 4, 5. And yeah, and that's carbon 6. That's 6. So that is what I have so far. And this is the Enolate here. Well, it's not an Enolate, but it's the result of that. We're going to protonate and form the alcohol here. So after I do that, let me see how I continue drawing. With acidic conditions, I am going to form the following. So I'm going to protonate here. And because I'm saving space, I'm doing this. So that is my same, so I'm going small arrow. Okay, that's that. So for the next step, so we did the removing the acidic hydrogen, nucleophilic attack over here. So this is intramolecular Aldol reaction. So it's going to give me that acidic workup, which is step 2. That's step 1, right? Step 2. And then when we have this is the Aldol products, with heat, this is going to dehydrate. So heat, and you're going to form an alpha beta unsaturated carbonyl compound, which is going to be this, removing here, we're going to form that. That's an alpha, so next to the carbonyl, alpha beta unsaturated carbonyl compound. And I need to go from this compound to F. So what I see here is that I have added an ethyl group. So the metal is already there. I have added that. So what do we use to add that? So the substrates, another good, say, Michael donor. This is a good Michael acceptor. It is an alpha beta unsaturated compound. So what we need to add the ethyl group is a different kind of Michael donor. We're going to be using the Gilman reagent. So in going from here to here, I'm going to be using Gilman, and I'm going to write down below what that Gilman is. So we're going to have ethyl, and this whole thing is negatively charged. Counter ion is lithium. What this is a source of this, the ethyl negative. That's my nucleophile. And what you're going to have is the attack over to the beta carbon. And that, when you do that, you're going to form this. So now I'm going to be erasing that part because we need the room to draw the product after the Michael addition with the Gilman. So I'm doing this. After I did this step to get to F, we're almost there. So we're going to be drawing this product after that reaction. So what is this interrogation sign? That's Gilman. And this is the structure that you're using. And now, after you move your electrons over, you're going to have metal, ethyl, which is what you just added. And this is an Enolate form. And acidic workup. And you will get the acidic workup and then the tautomerization step. So now, and this is the tautomer of that. So final step is then that's from here to, let's draw a big arrow over here. This is a tautomerization step. All right, so recap in this second part of the problem that we were doing before. So we started from A, which came from this structure. We have removed one acidic hydrogen. We did a Michael reaction in a previous video. Here, what I'm doing in the first condition is basic condition, ester hydrolysis, followed by acidic workup. We have the carboxylic acid here, and then this step was decarboxylation. Here we have in D, and in D you have removed one acidic hydrogen. This is an intramolecular aldol, so we're going to form a 6-member ring. Removing one of the H's here, you do a nucleophilic attack, and that is your intramolecular product. that is the alkoxide. Acidic water cup, which is number 2, you have this. And the heat, you're going to have the dehydration. So this product here, your Michael acceptor, is the Aldol condensation product. Aldol condensation is after dehydration. So this is the Aldol product. This is the Aldol condensation product. Your alpha beta unsaturated ketone. And then this works as a Michael acceptor. In your Michael donor is going to be Gilman. This is your Gilman. And you're going to attack with this over to the beta carbon that is in the enolate form, and that we have the keto form here. This is the tautomer. Okay.